For this first part of Lesson 3, we're going to take a look at a more traditional way of writing programs, sort of like how you would write it in PHP or C or C++ or Java or something. And then we're going to take a look at how we would write the same sort of programs asynchronously in Node.js, and this will sort of be the foundation for all of the asynchronous non-blocking Node code we write throughout these live lessons. So I'm going to go here to my text editor, and I'm going to open a new file, and I'm just going to write a little PHP test script to sort of demonstrate what we're talking about. Let's say I want to read a file in, open a file, read in all of the contents, and then dump it to the screen. In PHP, I would say something like this. I would say, let's open the file test.txt. I would want to open it read-only. We would then wait for that call to finish. Then I would say, read in the contents from that file, and let's say we would want to read in 100,000 bytes at a time or something. We would call that function, we would wait for it to finish, and then we would echo those contents to the screen, and then finally we would close that file down, wait for it to finish, and then we would have our script that runs like that. So actually, let's create this text file, and we'll put some garbage in it like that. Now I should be able to go here and say user bin php test.php. It reads in the contents of the file and prints them out exactly as I'd expect. There's really nothing surprising here. What I do want to stress or sort of emphasize though is we do each step one at a time and we wait for those to finish. So if I'm running a large web application or a web server that's doing this sort of thing, basically what I have, let's use the example where I'm opening a database connection and running a query and reading some data from there, I have to have a whole process running PHP in MySQL or PHP and connecting to MySQL as a database server. So I first do the DB connect, then I run the query, then I put it all together, generate the HTML, and spit it out. If I want to handle multiple requests at the same time, I've got to have multiple processes doing this work because each one is only doing one thing at a time and kind of blocking while it's doing the connect, while it's doing the query, and while it's generating the HTML. So the strategy here to support multiple queries and sort of doing a lot of work at one time is to run a lot of processes in parallel and sort of have the operating system's multitasking functionality help me with sort of handling multiple requests at the same time. It works pretty well, and this is really how a lot of, if not most of websites are run these days. The downside to it, of course, is that these processes do have a lot of overhead. They take up a lot of memory. On some web servers we were running, PHP and Apache would take easily 10 or 15 megabytes each. So on a server with only a gigabyte or a gigabyte and a half of RAM, I can only run 100 of these, which means I can only handle 100 requests simultaneously. And we started to wonder, is there a way to take more advantage of the available system resources and sort of get more efficiency? So let's take a look at sort of one of the core thing of Node.js, which is this asynchronous programming. So we're going to start out by looking at a very simple function that you might have seen if you've written some JavaScript in the browser, and that's the set timeout function. And what you pass to set timeout is you actually pass it a function to execute here. So we'll just have it do a simple console log, I am done. And then you also pass it a timeout, how long it should wait before it actually calls this function. So we'll say let's wait 3 seconds, and all times in JavaScript tend to be in milliseconds. Finally, we're going to say console log hello there, and that is our program. So when we run it, we say we first print out the hello there, and then we print out the I am done. So basically the way this program works is we first call the set timeout, which basically pushes this function onto a sort of waiting queue or a waiting stack and says after 3 seconds, 3000 milliseconds, then you can call this function. The set timeout function then immediately returns. We call this console log. We print out the hello there. And then after 3 seconds, we get the second hello, the second console.log called because this function executes. Now you'll see the script ends here right away, and there's no more code to execute, but Node knows not to exit because there's still one event pending. There still is one function on the event stack or queue waiting to be executed, so it only executes when both the function is done and all the scripts have finished executing and everything. So let's go back here and look at our file open program, and let's see if we could do something like that in Node, but take advantage of this asynchronous functionality. It would be cool if we could write this fopen function in such a way to say, go ahead and open this file, call the operating system, call the disk or something, and then tell me when you're done. And then when you're done that, then I'll start to read the contents from the disk. And same thing, that's all waiting for the operating system to do its work. So I'd like to be able to tell the read function, notify me when you're done, and so on. So let's write a little file loader here in Node.js. And so the thing we're going to do is I'm going to include this file system module, and we'll talk about modules in a later lesson for now, but for now, just need to know that to get functionality sort of included in your program, you're going to use the require function like that. So what I'm going to do is I'm going to say var f, and I'm just going to declare that. Now I'm going to use the fs open function, and I want to open test.txt. I want to open it for reading. And then the last thing I'm going to do is I'm going to give it the name of a function, or I'm going to give it actually an actual function to call when the file is open. And this function will be given an error and, most importantly, a file handle. Okay, so when this function is done, I'm going to say f is that handle. Now, once I have that handle, I want to say read from that file. And to read, I first need to create a buffer, and because reading in JavaScript and Node is all done with these buffer objects that can handle binary data. So I'm going to read from the file handle f. I'm going to put it into buffer. I'm going to put it at this sort of index 0 of the buffer, and I want to read the same 100,000 bytes. I have to put a null here, and then I'm going to take a function, and it's going to take an error and the number of bytes actually read. Now what I'm going to do is I'm just going to say console.log b.toString, and I want to tell it to print in UTF-8, and then I want to start it at 0, and then the actual number of bytes read. And that is pretty much all we need to do. And then I can also say fs.close like that. So this should let me open my file, read it, and close it. And if I haven't made any spelling mistakes or anything like that, it should work. Oh no, something bad happened. Well, the actual problem here is this file descriptor, the first parameter we've passed in. Let's do a console.log here on f and see what happened. If I run the same program again, you'll see f is undefined. So that seems a little weird. I have f here. I tell it to set the handle we get from the open to f, but by the time I get here, it's null. So what's happened? Well, we've actually written this program incorrectly, and I just wanted to sort of demonstrate a sort of common misconception about how these asynchronous programs work. So I call the fs open, and then I say, which tells the operating system to do its work, but then it says, call this code when you're done. Until this function is called, you actually don't have an open file or a valid handle. So this function call is not called until probably way down here when all the other code is executed. So what this program is currently doing is it's saying, open the file, great, call this code when you're done, but now create a buffer and start reading from this file handle. But I don't actually have a valid file handle yet, so the program gets all confused and bugs out on us. So what I'm going to do is actually execute the code like this. Now I'm going to say var f equals handle. So what I'm going to do is when you're done opening it and you calling this function here, now you can go ahead, do the read, and then do the close after the read is done, like that. So you wait for each step to finish before you start executing new code, like that. So first I do the open, then the function that is told when the open is finished, create the buffer, I start the read, then the function that has the data from the read does the printing, and then it goes ahead and closes. And in fact, the close function is asynchronous as well, but we don't really care about the results from that, so we don't bother passing it a function. So now, if I say node fread, you'll see it works just fine. It goes ahead and reads in the contents of the test.txt file and prints them out. So you may be wondering how this is sort of working and not exiting right away, because basically all we do is we say fs open, call this function when you're done, and then that's the end of my script. It should just sort of exit and fall off the end here. Again, as we explained with the previous example, however, what is really happening is Node is saying, well, even though the script is sort of finished executing, there is still a function waiting to be run, so I'm not going to exit until that happens. Then I call this one and I push a new function waiting to be run, so Node still knows, don't actually exit the script until this is all done. So what I'd like to do now is sort of demonstrate the sort of node way of doing things, and that is there is only one node process here executing at any given time. I'll start my code here, and let's say we're going to run a open call. We're going to do some disk I/O, and this pushes an event or pushes a callback onto this sort of event stack or sort of listeners or sort of code waiting to execute, this sort of stack of things waiting to happen. We then get signals or reports or events from external sources. For the fopen, for example, I'll get a notification from the operating system that the disk file open is done. If I were doing a database call, I would maybe do a query, push that. The database would say the query is done. Maybe I'm trying to run a little web server or something. I'll do a listen call here, and then I'll get a connection coming in. When one of these events is triggered, when the operating system is ready, we pop the event from the stack, we execute the code, and that code can actually push even more. It can do things like console.log, it can end responses, it can do whatever it wants, and you just end up in this loop. And as long as there's some event waiting to run here, there's something, we're listening for something, we're waiting for something, Node will keep running. And it's only when there's no more of these done that Node says, okay, I guess I can exit. That is the sort of basic asynchronous way that we'll be doing things in Node from now on. We will just always be calling functions and then giving a new function to execute when that function is done. And then we can either just print things out, we can send responses to clients, or we can further call new functions that cause other things to be done. And this is our sort of asynchronous, the asynchronous world we'll be operating in from now on.